Hi everyone, we're going to add a new shortcut. We're going to add the product rule, which helps us deal with how we take the derivative of the product of two different functions. So this one will be a little more like when we found the sum and difference shortcut, in that we're just going to have a generic f of x and g of x to represent our functions. We're trying to find a rule that works for any pair of functions, unlike the trig shortcuts where we were trying to find a rule that just worked for one very specific function. Okay, so I'm going to start as usual by setting up the definition of the derivative. So we want the limit as h approaches 0 of our function evaluated at x plus h. And this might be confusing because part of our function is f and part of our function is g, but basically we're just plugging in x plus h to both pieces of that. So we'll need an f of x plus h times g of x plus h. And then we're going to subtract off the original function, which is f times g, and that's all over h. So we actually have to get fairly clever in this one, but it's a beautiful trick. It's so cool. So once again, you don't have to memorize how to get the shortcut. You just have to memorize the shortcut. But please watch through this so that you see where these are coming from. I think it's a really important piece that you're getting a little of that higher level math thinking. Okay, so the algebra trick that we're going to use here is to add 0. So we get to use multiply by 1 a lot, like multiply the top and bottom by the same thing. That's multiply by 1, and we do that all the time to simplify fractions or rewrite fractions. Now we're going to add and subtract the same thing in the numerator of this fraction. If you add it and subtract it off, that's really adding 0, so you haven't changed the value or meaning of your fraction, you just changed its appearance, and it doesn't have to be a fraction, but this one is a fraction. Okay, so let me get started on this one. The limit as h approaches 0, and then I'm going to write down that first piece that I had, and basically the way we choose what to add and subtract is by seeing what we could do to be able to factor out a g of x plus h. And I'm hoping to end up with a difference quotient when that happens, so I want this to be a minus. So I want to be able to factor out a g of x plus h, and to get the f of x difference quotient, I would need an f of x in here. And then to balance that out, I need to add the exact same thing. And then I don't want to forget the f of x g of x that was at the end, so I don't want to lose that. Okay, so I've added 0, and now I'm going to split this fraction in half right here and see if I can work on it from there. So we're going to have the limit as h approaches 0. So for the first fraction, I'm going to do two things at once. I am going to split it into two fractions here, but while I'm at it, I'm going to do something similar to what we've seen before. I'm going to factor this g of x plus h out. So I have g of x plus h, and then what's left in the fraction is f of x plus h minus f of x. So when we factor that out, what we're left with is a perfect difference quotient for f. And again, just so you can see it, if I put that over 1, I could just multiply it right back in, so it really is equal to what I had before. I just want to separate the g's from the f's this time. Okay, so after the division of the two fractions, I just kind of added in that g of x plus h times f of x because I had to balance out what I did before, but it works out in kind of a neat way. I can factor an f of x out, and when I do that, what I'm left with is a g of x plus h minus g of x, and that's all over h. So coincidentally, I also get a perfect difference quotient for g at the end of this whole mess. So now I'm just going to think through each piece and what happens as h goes to 0. So as h goes to 0, out in front here, we'll just have a plain old g of x, and that will be multiplied by f prime of x. That is the definition of the derivative right there. The limit as h goes to 0 of f of x plus h minus f of x over h is f prime of x. And then we have the plus. And then the f of x is just f of x. Nothing happens when h goes to 0 because there is no h, but that gets multiplied by g prime of x, right? We're taking the limit as h goes to 0 of g of x plus h minus g of x all over h. And this is what we get for our product rule. So this is the derivative of f times g. And it's nice when you're trying to memorize these to think of a way to say it to yourself. So I will tell you my way, but I'm sure you could go on YouTube and search how to memorize the product rule. And you can probably find songs and all sorts of tricks for how to memorize it. But this is mine. So I think about it as first function, second function. And the way I say it to myself is I need the second times the derivative of the first plus the first times the derivative of the second. So that's how I say it in my head when I'm trying to set this up. The truth is the product rule is very forgiving. Multiplication doesn't care what order, so you could flip-flop whether it was the function first or the derivative first. Addition also doesn't care which order you do it in, so you could flip-flop the second times the derivative of the first with the first times the derivative of the second. What's really key is that each function gets multiplied by the other function's derivative, and then you add those two things together. But having a nice way to say it to yourself so that it sticks, I think, is really important as we're learning these shortcuts. All right, that's it for where the shortcut comes from. Make sure you memorize this deal right here in whichever way works best for you. Thanks for watching.